Hello students. So in the last part we have studied the normals and the pair of tangents. I hope that you have understood it. In this part I am going to start with the diameters and polar form. I am also going to tell you that how you can draw an ellipse with respect to two perpendicular lines and how you can find its equation. So instead of looking at some points or some planes to draw, you just need only two perpendicular lines to draw an ellipse. So we'll see how we can derive its equation and many other things. Let's start.
Chord of contact. Now we know that what is a chord of contact. A chord of contact is, suppose that if you have any point x1 y1 that is outside, and we know that from a point outside we can draw two tangents. So what we are doing here is we are joining the point of we are joining these 2 points, the point of contact of tangents, and if we join these 2 points, the chord that comes out, we say it to be chord of contact. The equation of chord of contact is given by t equal to 0, where t has its usual meaning. Now remember that t equal to 0 refers different things at different times. If the point is on the ellipse, t equal to 0 refers tangent. If the point is outside, then t equal to 0 represents chord of contact. So let's check our concept on this thing. From a point O on the circle, that means there is a circle given, x square plus y square is equals to 25, tangents OP and OQ are drawn to the ellipse. That means that this point O is outside the ellipse and it's on the circle. So I can clearly say that the coordinate of O can be 5 cos theta and 5 sin theta, the parametric coordinate of circle. So from this point, two tangents are drawn and we need to show that locus of midpoint of chord PQ described is the curve this. That means the locus of midpoint. So what is happening here is that suppose you have an ellipse like this and you have a circle. Now from this circle, you're drawing two tangents, one like this and one like this. Now these two tangents, as they are touching, so from these two tangents we can draw chord of contact. So this is chord of contact and this is the midpoint. Now I can write the equation of this same line PQ, this is P, this is Q, this is O. I can write the equation of PQ in two forms. One is by using the chord of contact and one is by using equation of chord whose midpoint is given. Because we need to find out the locus of midpoint, let's say that the midpoint of this chord be h comma k. So I can write that. Now first of all, what I am going to write is equation of chord of contact. For this ellipse, it is given by 5 cos theta x divided by a square, that is 4, plus 5 sin theta y divided by 1 is equal to 1. This is the chord of contact. Now I can also write the equation of chord whose midpoint is given by using t is equals to s1. So t is equals to s1. If I write this t is equals to s1, what I am going to write is hx by 4 plus ky by 1 is equals to h square by 4 plus k square. Now I am saying that these two equations are equal or the same. If these two equations are same, so what, upon comparison, I can write 5 cos theta by h is equals to 5 sin theta divided by k is equals to 1 divided by h square by 4 plus k square. From this equation, I can clearly see that the value of cos theta is 4h divided by 5 of h square plus 4k square. Similarly, sin theta will become 4k divided by 5 h square plus 4k square. Now it's very simple. We need to square and add these equations. When you square and add these two equations, replace h comma k with x comma y and you will get the same thing. For example, if I write this replacement, what I am going to write, 16h square divided by 25 h square plus 4k square plus 16k square by 25, again the same thing, h square plus 4k square is equals to 1. So take this denominator, the common denominator on the other side, and you will see that this form is coming. So this is how you need to solve this question. Moving on to the next concept, that is polar form. Now again I'm explaining what is polar form. So this concept again goes for it's again a general concept like the previous chord of contact. This this polar form is also a general concept. You can apply it to any part of the conic section. Let P be any point inside or outside the ellipse. So let's say this is our ellipse and this is the point P. It can be inside or outside. From this point P, a variable chord is drawn. So a variable chord is drawn and it intersects ellipse at Q and R. So these are the two intersection points at Q and R. From these two intersection points, I can draw two tangents like these. So these are the two tangents. Now the locus of point of intersection at Q and R. So at Q and R, I have drawn tangents and these tangents are intersecting. The locus of this intersection point that we are talking about. You can draw a chord like this, you may draw a chord like this, you may draw a chord like this. So at each and every these points, what you are going to do is that you are going to draw tangents. So these tangents will again intersect. The locus of all these points of intersection is called as polar. That means this line is our polar. Again, remember its locus of point of intersection of tangents at the extremities of chord. And point P is called the pole with respect to the polar. That means this P point is pole with respect to this polar. Now equation of polar. So the equation of this polar is given by again T equal to 0. Now here the point T equation T equal to 0, the point x1 y1 which is our pole, it can be inside or outside as well. So here this point P is actually a pole and the equation is again T equals to 0, where we know what is T. T has its usual meaning. Let's do a question on this. So what we need to do is that find the polar of focus with respect to ellipse. That means your pole is focus. Now if this is the ellipse, I know the coordinate of focus. The coordinate of focus are a, 0. So this is my x1, y1. Or rather I can write it plus minus a, 0 so that both the focus I take into account. Now find the polar of focus for this ellipse. Now we need to find equation of polar. We know that equation of polar is T equals to 0. So if I write it a plus minus ae x by a square. Now there is no y, so 0 minus 1 is equals to 0. That means 1a I can cancel out with a square. That means I get x is equals to plus minus a by e. If you look carefully, this is directrix. So guys, remember this is a very important point to note down. It's a direct result and it's actually a very simple that polar of focus is directrix. Polar of focus is actually corresponding directrix. Okay, so if you are taking focus of one side, then the corresponding directrix will be its polar. Let's solve one more question. So if polar of ellipse is given by this, then we need to find the pole. Now here the question is reversed. Here we have given with the polar. This is the polar and we need to find the pole. Now we know that if this is polar, then it has to be of this form. x1 x by a square plus y1 by b square minus 1 is equals to 0. This has to be of this form, where x1 and y1 are your pole. If I try to make the equation in this form, that means what I need to do? I need to make the coefficient of constant 1. So if I do this, then what I'm going to get? I'm going to write it like this. Lx by n plus my by n plus 1 is equals to 0. Now there is one more thing. You need to make this 1 as minus and you need to have a square b square here as well. So look what I am doing. Minus L by n, I have to multiply with a square as I am going to divide by x a square. Minus m by n into b square, I have multiplied with b square because I need to divide by b square. Minus 1 is equals to 0. Now if you compare this equation number 1 and equation number 3, what is my x1? My x1 is this thing. That is, my x1 is minus a square L by n. What is my y1? My y1 is again this whole thing. My y1 is minus b square m by n. So this is your poles. Remember that we need to bring it into the same form, x1 by a square, y1 by b square minus 1. So upon comparing equation number 1 and 3, I can clearly see that the coordinates of x1 is this and the coordinate of y1 is this. So in this way you can find the pole if polar is given. Let's move to the next concept, that is diameter. Now what is a diameter? Diameter is actually the locus of midpoints of a system of parallel chords. That means there are parallel chords, maybe 2, 3, 5 or any number. All those chords have to be parallel. If you find midpoint of each of these parallel chords and if you join them, you will get a straight line, which is a diameter. And the endpoints of diameter, that means the points at which the diameter intersects the ellipse, they are called as vertex of diameter. So let's see it visually. Suppose that this is our ellipse. Now system of parallel chords. Let's say this is one of the chord, this is the other chord which is parallel, similarly another parallel chord. So if these are the parallel chords and if I join their midpoints, so I'll get a line like this, which is the diameter. So this is the diameter. It is passing through the midpoints of all these chords, and these 2 points, this point number 1 and point number 2, these are called as vertex of diameter. Now again, if there is something, then we are interested in its mathematical form. We are interested in its equation. So equation of diameter is given by, now we have to fix one thing here. We have to fix the slope of all the chords, because actually they are a system of parallel chords. So the unique thing that they have is slope. If you vary the slope, your diameter will change. So what I am saying is that fix and slope. Draw the chords with the same slope. If you draw the chords with the same slope and join all of them, then the equation of diameter will be this. Remember that this is the point which is differentiating each and every diameter from other. As soon as the m or the slope changes, the system of parallel chords will change and the equation of diameter will change. Remember that this diameter is with respect to this ellipse. So what you can do, if your ellipse changes, then again you have to write your equation of ellipse in the capital X and capital Y form, and then you can proceed. Now we'll move to the last concept of this chapter, that is the ellipse with respect to 2 perpendicular lines. Now what we have done is that we have taken our ellipse to somewhere else, we have rotated it as well, and we have done many things. Now the final form of equation of ellipses comes when you are given with 2 perpendicular lines. Now remember that you need only 2 perpendicular lines to plot an ellipse. You can do that with 2 perpendicular lines very easily. Look what happens here. This is a general ellipse. If we have this point, let's say x comma y, and these are the 2 perpendicular lines which you may feel as axes, then how I write my equation? I write my equation as x square by a square plus y square by b square is equals to 1. Now what are x and y's? If this is any point P, then x is perpendicular distance on one of the line from that point. Y is perpendicular distance of that point from the other perpendicular line. So this x and y are actually perpendicular distance of point from those 2 perpendicular lines. A square and b square have their usual meaning, that this is A and this is B. So if you know the values of A and B, that is the semi-major axis and semi-minor axis, you can draw or you can find out the equation of any ellipse with respect to 2 perpendicular lines. Suppose that this is the ellipse whose equation we want to find out, and let's say that our origin is somewhere here. Now I don't have any relation with origin to these points. Remember, previously we used to have the coordinate of center known, so we can write that easily, but here we don't have. So what I am going to do, I am going to use the equations of these 2 straight lines to form the equation of ellipse. Let's say the equation of this straight line is given by ax plus by plus c1 is equals to 0. Equation of the perpendicular line to it will be given by bx minus ay plus c2 equals to 0. So you can clearly see that these two equations are perpendicular equations. Let's say we have any point h comma k. Now remember that a and b are known. As I have said that semi-major axis and semi-minor axis values are known. Now how can I draw this? Drop a perpendicular from this point on this line. Okay, from point P to, let's say, this L1, and from the same point P to this L2, and that's it. So what equation I am going to write? I am going to write it as AH plus BY plus C1, sorry, this is BK plus C1 divided by root of A square plus B square. This is my X. So X square divided by A square. Let's say capital A be the length of semi-major axis, so as to differentiate this A with this A. Plus length of perpendicular from second one, from second perpendicular, that is what I am going to write, BH minus AK plus C2 divided by square root of B square plus A square whole square, because this is y, divided by capital B square, that is my semi-minor axis, is equals to 1. So this is my equation with respect to two perpendicular lines, equation of ellipse. You can simplify it. I can clearly see that it will come again to this form, which will give you ax square plus b plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. Now these a, b, c's are different from these. So let me name them a dash, b dash and c dash. So this equation which is written above can be simplified into general 2-degree equation, and then we know how to resolve. Or if you have an equation in this form, you can straight away solve things like this. Let's assume this be capital X and let's assume this be capital Y. And again solve for capital X and capital Y. Your equation will be capital X by A square plus capital Y by B square is equals to 1. Now we know with respect to this capital X and capital Y what are all these things. For example, center is X equals to 0, Y equals to 0. Directrix is X equals to A by E plus minus and so on. Focus is X equal to plus minus A and Y equal to 0. So using this capital X and capital Y and then replacing capital X by these values, you can solve. Now, so in this way we have formulated the equation of this second ellipse in mathematical form. Now remember, you may ask me that which is the major axis and which is the minor axis. That you have to figure out. As I said that the values of A and B are known, so whichever is bigger, that is your major axis, and whichever is smaller, that is your minor axis. So moving on, this is the last concept that we have studied. This was an important one as well. So do remember this thing.
So I hope that you have studied how to write the equation of pole, polar and diameter. Also, the equation of ellipse with respect to two perpendicular lines is important and you need to remember it. Now, here we end all the theory parts. In the next part, I am going to solve some of the JEE questions. You will feel that based upon these theory that we have studied, these questions are actually easy and they have asked in JEE. So that will build your confidence as well. So stay tuned for the last part.